Thanks everybody for coming to the last session of the first day. I'm sure there's a lot of stuff that's going to be happening after this. My name is Ryan Hipple. I'm a senior engineer at Schell Games in Pittsburgh. And this is the hack spectrum, tips, tricks, and hacks for Unity. I'll start by telling you a little bit about Schell Games and some of the big projects we're working on. Primarily, Schell Games does what we call transformational games, and those are they fit under the educational game umbrella, or actually they are the umbrella that fits educational games, but in a much cooler way. And we're working on a game called The World of Lexica, which is a transformational game, and it's going to be given to kids in schools on tablets, which is a lot of fun to be working on this. You probably all grew up playing Oregon Trail. This is hopefully going to be the Oregon Trail that you play. The game's a lot different, though. I would say, I always compare it to Kingdom Hearts. It's like if you're playing Kingdom Hearts, but instead of Disney characters, you're connecting to characters you meet in English literature. So Frankenstein's monster, Tom Sawyer, and it's an adventure game where you go around and meet those people. It is not a small project by mobile standards or by Unity standards. It's a 50-person team on average, and we've ramped up, we've ramped down. And it's been going on for 2.5 years, actually a little more. We just hit QA earlier in the week, which is good. And if you think about that, that's 125 man-years of development time. So whenever we come into small problems and things that we can fix in the editor that will speed up the development process, it's usually worth taking the extra time to do that because of the overall scope of the project. I've spoken a few times at Unite before, and it usually starts the same way. I think of a bunch of little cool topics that we figured out in the studio, usually solutions to little annoying problems in the Unity editor. And then I try to build a theme around those, and I present that as a whole. And the theme is usually some game system that we wrote and all the little pieces, all those little tips that we learned building that. Well, the problem is I end up cutting material that doesn't fit the theme because it always ends up running long. And at that point, I end up losing some of the tips that I originally wanted to present. So I want to do things a little bit differently this time. You can think of this almost like B-sides, where I'm just taking all of those things that I always wanted to talk about, but they just never completely fit a theme. And there's also some stuff that, that we've learned recently in development that I'm going to present today. And they're going to be things that some of them are just quick little editor scripts you can write to solve some common annoyances, and some of them are dirty reflection hacking into the Unity engine. And where things lie on that spectrum should be a little self-evident. I want to talk a little bit about serialization and some of the techniques we use for that, solving some of the serialization problems. Our asset pipeline, some of the things that we've used in our asset pipeline to help smooth out the process with so many people on the team. Runtime, there's not a whole lot of topics on runtime because you shouldn't really be comfortable doing dirty tricks on device. And I want to talk about reflection a little bit, which is sort of the basis for a lot of our really cool editors tools and some of our really nasty hacks. I'll start off talking about serialization, super serial. Polymorphic serialization is one thing that everybody talks about, how they want to do this in Unity. And that's just because polymorphism is awesome. From a standpoint of software development, it's one of the most powerful tools you have in an object-oriented language. If I can take an object of a base type and inherit from that type, and then be able to treat all of my sub-objects or objects of that subtype as the root type. I'll give you an example because that's a little difficult to explain. But Unity does not serialize this well, either as a field structure or as an array structure. If I have an array of some superclass, I can't just pack in a inheriting class object and expect it to give me that data. So for example, if I have an abstract base class animal, and that is something that we want to instantiate because it's abstract, and that has a field name. And we extend the abstract base class animal to have a class man, bear, and pig. We'll see that both man, bear, and pig will all inherit the same field data that they get from animal, and that's name. So they'll have this data. That's great. If we want to serialize out a bear into an array of animals, or a field whose type is animal, either in a scriptable object or a prefab, well, first, there's also specific data we want to add to each one of those types. So for man, maybe intelligence, a bear, ferocity, a pig, of course, deliciousness. And if we want to serialize these out, what we'll find is those specific fields that we add get lost. And this is really frustrating, and it means that just polymorphism, just right out of the box, is not straightforward to serialize. but we serialize it, and here's how. We start off by, instead of making everything serializable, we serialize, we inherit from scriptable object. So animal would inherit from scriptable object, and then by proxy, all of its subclasses would also inherit from scriptable object. We then create an instance of that, and when we add that to the list, then that instance stores its own type data, so it knows what fields it has. There's a problem with this solution, is that it makes lots of files. Your Unity solution is going to look a little bit like this, which is kind of frustrating, because this is really the only file you care about, your animal list, and if you move that around, it won't move the subfiles. If you delete it, it won't delete those files that you just expect to be part of that data. And if you make a duplicate of it, it is not a deep copy. You'll make a duplicate of this object, and it will just point to all of your other assets. So this doesn't fully solve the problem. To get a better solution out of this, we're going to take advantage of something to get it all into a single file. And Unity has, in the asset database, a function called add object to asset, which is really cool. It isn't something that is private or anything that's super hidden. It's just not something I see people talk about too commonly. Add object to asset, you specify the object and then the path you want to save that thing into, and it will actually add everything into one file. So source control will see this as one file. If you drag and drop the root of this, it will move it as a file. And if you duplicate that, it will make a duplicate of all the items and maintain its internal references. This is really cool. You can collapse that down, and it'll look just kind of like one file. If this isn't enough, if you want to make it look a lot more like a normal file with a list, you can set the hide flags on each one of those sub-elements. And if you set hide flags to hide in hierarchy for man, bear, pig, man, bear, it will hide those, and the only thing that can show is the root animal list, and it'll look like it's a normal file. And I'll show this in a demo in a little bit. But first, I want to show a little bit about why this works this way. I recommend looking at your text serialized files just to understand a little bit more about how Unity does serialization, and it's just fun to mess with them. So I also created another class of failed animals, which represents the case that doesn't work, and inheriting from that, of course, is dodo. So dodo, here's a dodo with the name field. It inherits from animal, derp, and then its specialized field is amount of fail. If I take that and I serialize it out into a list of failed animals, this is exactly what I talked about before, you lose your specific, your extra special field that gets added to that. You can see the difference with the solution of the scriptable objects. This list here, the animal list, it doesn't contain the data. It contains a reference to an object. And this file ID is a little bit of a confusing name. The file ID is the ID of an object inside of a file, not the ID of the file. The GUID is often the ID of the file. So you can see that this O2 is the same ID you see right here of this mono behavior. So it creates an internal reference to the file, which is why duplicating that file works. And in here, the important thing to see is that, oops, this has the mscript field, and the mscript field specifies the type with the combination of the GUID and the file ID. And that's why this works, because you are not relying on your list to define what the type is. You actually store your type in your asset. So we can clean up the polymorphic serialization that we deal with by creating custom inspectors to make all of this stuff seem automatic. And what we do is when you add an object to the list, you can call create instance, and that will make the asset, and that's when you add the object to the asset. When you delete an object from the list, you call remove. That keeps things nice and clean so you don't have orphaned data sitting around. And you make a drop down to select what type. So you have to specify somewhere that, am I going to make it, you can't make an animal. Is it going to be man, bear, or pig? It can't be all of them. It would be terrible. So this is going to be a little tough because the screen is gigantic behind me. Let's try it out. All right. So here's my animal list. Here's my animal list. Here's the example of the failed dodo and this list of failed animals. I made a quick button here. This creates a dodo in memory, assigns all the fields, and then puts it in that list. So I'm assigning data to those fields. But as soon as I enter it in that array, I lose the data, which is frustrating. So again, we know it's a problem. Here is the animal list. I can find a better place to stand. If I click this add button in this custom inspector, it will give me this type selection. So I'm going to add 3. this will let me decide what type I want it to be. So you can see what it did over here is it actually added those into the asset file. And this is treated as a single file in Unity. You can collapse it. If I call this hide, this just sets the hide flags on all those sub-assets. So it will hide it and it looks like one thing. The cool thing here is if I click one of the list elements and I double-click it, it will take me to edit that. So you can still edit your data even though it doesn't show up directly in the inspector. This type dropdown I want to quickly talk about because there's a pattern used here that I use in a lot of places to solve a lot of awesome problems. Except for this one. Animal list inspector. This is the magic that makes that dropdown work. When this inspector initializes, it will reflect over the executing assemblies to find all objects that inherit from animal. So you can get all of the currently executing assemblies with get assemblies on your app domain. You loop through each one of those, and you ask that assembly for all of the types that it has. If each type that it looks at, if it is not abstract and it inherits from animal, it adds it to a list. And that's how we build up that list, and then just on GUI to draw that list that lets you select your type. And then we create our scriptable objects after that. Too many switching. The other thing that Unity does not serialize very well are long 64-bit integers. So this is a little inconvenient because longs are really good. It's a really good type to use for IDs because it's very nice to get pseudo-unique numbers with it. And similarly, you might have external applications that use longs for IDs. We're working with another system that uses item IDs as longs, and we need to serialize that out. It's nice to be able to treat this as a single item and not have to just always serialize it out and do some conversion on a type like a string or whatever. So what we do for this, oh yeah, Unity does not serialize it, but we already know that. It serializes string, just doesn't do long. So what we do for this is we break it into two ints, which is a little straightforward. We just bit shift it to get high order and low order bits. And if we do that, then in the inspector, it will draw like this. And that isn't great. That's a little, doesn't really show us a representative value for the long. It's not how anybody really represents that value. So we do a custom inspector that makes it show up like this. So give it the hex string for it, which you can copy and paste between any software that's trying to represent the long. This is usually the format you're going to see it in. And another important part of this is to do implicit casting between longs and your serializable long. So you can just substitute that in code, and it'll take care of itself. Something else we want to talk about, this is actually a type of serialization, is your assets. First, I want to talk about data-driven assets, so scriptable objects. Creating scriptable objects is kind of a pain. If you're creating a model behavior, Unity gives you a really nice interface for that. And it lets you select from this dropdown all of the model behaviors you've defined. You can even type in a search box to filter what type of model behavior you want to instantiate on that object. But for scriptable objects, it just doesn't really give you anything that nice. You just have to do it in code. It's not that it's a difficult bunch of code to do. It's just kind of frustrating to just have to always do that. So in order to just reduce having to do this for every object that we have in our project, you can do something really cool, which is create a custom editor on monoscript. Custom editors are a very powerful feature in Unity. You can define what type. You can define a type and how you want to draw it in the inspector. I will probably slip and call them custom and call them inspectors instead of custom editors. I always do. But if you make one for monoscript, that will be something that will draw GUI in the inspector for every C# file you have in your project. And at that point, when you're doing that draw, you can check to see if that type that's represented by that file inherits from scriptable object. And if it does, draw a button to create the instance. So this is a nice quick way to not have to write new code every time you have a new type. And this isn't really meant to show you exactly how it's done. This is mostly meant to show you the simplicity of this is the entire script. This could be the last scriptable object creation thing you have to write. I'm going to demo that and another type of scriptable object creation feature. Yep. If I open my scripts, if I click on my animal list, you can see there's a create instance button. If I click on this attribute thing I've defined, it just renders like a normal script file. animal list, create instance. And there it is. It'll create a new animal list for you and put it down here. And it's the same simple drawing code that you, or the same simple object creation code that you would use from any script. Another thing that we've defined here using a pattern I'm going to repeat over and over again is if you go to create scriptable object, and you can add something to this create menu with the menu item command. And that's going to pop a window up, of course, on my other screen. And this is going to give you a list of all of the scriptable objects you've defined in your code. So I can click this and create a new one. The way that that works is here I'm doing a similar pattern to when I was stepping over all the types for things that inherit from animal. But instead, on awake, this is looking for all of the types in the current assembly that inherit from scriptable object. And then it's also saying ignore things that are editor windows or that are abstract so that you don't end up getting a thing to create those. And that again could be one of the last times you have to write scriptable object creation code. And so after I've realized that I could write a custom inspector for monoscript, which felt kind of cool, I wanted to see what else I could write custom inspectors for. So I tried to make an inspector, a custom editor, for directories, and I couldn't. There's no type for directory. It's just not a type. Same with Unity files, which is kind of crazy to me that they still don't have a data type for Unity or for a scene file. If you have an object with an unknown extension, you can't really hook into that super easily either. And if you have an asset root, when I showed you the demo for the animal serialization, when you nest them all in the same object, the root of that actually loses its type information. So you can't just easily say, I want to make an inspector for this type of thing, because there's no type defined for that, except for the base of all things, which is object. So if you make a custom inspector of type object, or custom editor for type object, and then what you need to do is you need to find a way to draw differently for each type. And you could do that with a bunch of if statements, but that's really ugly, not extensible. So instead what we do is we copy the inspector pattern that Unity uses, which again reflects over a bunch of types. You can, by extending a certain class, you can get a list of everything that wants to inspect object types. So our specific solution is we make that custom editor for object. So this is going to draw anytime I have selected a directory, an unknown file extension, a scene, or a root asset. And then on enable of that inspector, use reflection, step through all of the types in your assembly, and find everything that inherits from object inspector, which is a class that we are defining. And we define object inspector, and that has to specify we're going to use as assembly.getTypes to get the types. Our object inspector has to specify a function called isValid, and we pass into that the path of the asset, and the individual instance here or the individual object inspector class that we're defining has to define the criteria necessary to say that this will draw this file. And then on inspector GUI, we draw that. So a super quick example to show you how easy it could be is you extend object inspector, define isValid, and a good example for that is if the extension equals .unity, then this thing will be used for any scene files. And then you override on inspector GUI. Let's try to demo this without turning my head around too much. That's not possible. So the scenes directory, you can see that there's a inspector that gets drawn here, but not for these directories. And the reason that is because the criteria I've defined for a scenes directory is anything that, anything that is a directory. So once I have the path, I can determine it's a directory. And if it contains a file that it has a .unity extension, that is now treated as a scenes directory. This inspector shows how many scenes we have in there, and it has a button to create a new scene. Creating a new scene is usually awkward, and you end up getting the save menu, and everybody stores it in a scenes directory. So just have a button here that will create a new scene in the directory, and you can see the scene count is now updated to 3. Another inspector type here is for the unknown file type. So here we have an unknown file type, a .wtf file. And the contents of this file contents of this file is a base 64 encoded string. So it's not very human readable. So what we can do with this, now that we have an inspector that says, OK, I only look at .wtf files, it can determine what does it do with the contents of that. So this is going to load it all and decode the base 64 string into a regular string. And I can edit this to say something new. Save that, and then switch back to this, and it will tell us it's re-encoding and writing something new. So if you have any external file formats, even XML or anything like that, you could define some special inspector that lets you edit that in place without having to go to an external file. And I will just quickly open the, maybe I won't. No, I'm not. I can open that up at the end. Another problem that we attempted to solve, and solved, I think, pretty well, is importer settings. This window is opened very frequently during the beginning of a project to figure out the settings you need to have for each of your assets. And then programmers usually yell at their artists and say, no, you need to check read-write enabled on this type of file. And it's a little annoying that Unity doesn't do this, doesn't let us share those importer settings across everything. You can shift select and batch select a bunch of objects and then edit their importer settings at the same time, which is nice. But it is not really automatic. And we really want to do either per project, or more specifically, we want to do per directory. We want the characters directory to import things a certain way. We can have the props directory put compression on the meshes if we want. And the other thing is it needs to be automatic. So when a new file comes in, this needs to be applied right away. We shouldn't have to specify it manually on the file. Our solution for this actually has two parts. The first part is to use the asset postprocessor script. If you have a script that inherits from asset postprocessor, you will get a function called every time an asset is about to be imported. So if you have an FBX file that's about to be imported, you can modify the importer settings. So the next half of this is how do we configure those settings? And what we do is we create a settings object that lives per directory. So each directory can have one of these settings objects in it that defines how it's going to change the assets that live there when they get imported. And each one of those settings files can import can optionally override some field inside of the importer. And it'll apply that to new assets. So if you drag and drop a new asset into your Unity project, it will pick up that settings on import. And I'm going to try to demo this now. Art directory. That's where we keep the art. In the props directory, you can see, let's turn one of these off. So there's no mesh compression on the podium, and the dummy has a medium. Oh, wow, I didn't realize I put a dummy behind a podium in this one. I really did not realize that. Oh, God. All right, so I'm going to put new assets in. I wrote a custom directory inspector for my props directory here. So the rule for this is anything that has an FBX file in it becomes a model inspector directory. So I use this solution a lot. It's something that I built off of for a lot of these other problems we're solving. Create settings override object. And now the custom directory inspector knows that it has an override object, so it'll show us this menu. This has a handful of the options in there that we've had to tweak. We didn't port everything over into this because we've only been doing it as necessary. But the way this works is I say I want to override mesh compression, and I want everything to be high. When I hit apply, it will re-import everything in that directory. And now the dummy is high. Oh, no. And the podium is high. Yeah. Another cool thing about this, I totally should have put this in there. I should have put the dragon behind the podium and brought in the dummy. But here is a new asset of a dragon. And if I drop this in on import, it's going to apply those settings, and we're going to have a dragon that's high. So the mesh compression on this is high. It just happens on import because it's in that directory. And switching back, I think. Yes, this one. Metadata in Unity is a fun thing. You can see the way that the asset importers work is they store all of those importer settings in the metadata. And that's a really useful thing to have because you don't want to know at runtime what the mesh compression was. So it's nice to have a separate file that doesn't need to be pulled in at runtime. It's data that is about the file. It describes it. It doesn't need to be in it. And it's often going to take too long to load the entire file. So if you have a scene and you want to know how many objects are in that scene, you shouldn't have to load the entire scene to count them all up. If you had a script that wanted to know something like that, just loading the entire scene could take minutes, depending on your project and your computer. So it doesn't make sense for all that data to live inside of it. So that's fine. We just push it out and save it into a scriptable object that, I don't know, has the same name, same path. But that's a little sketchy because those can get easily deleted or renamed. And you can see those in the inspector, so people are going to be clicking them and possibly deleting them at that point. Unity does this already. They store it in the meta file. And you can actually shove data into the meta file as well. An interesting story with this is I thought I was doing something really dirty when I started doing this. And I was loading the meta file as a text asset and changing the text in there. And I realized that Unity didn't change it. So I just kept doing that and was writing more data in there. And then I felt less cool when I found that there's an API call to do it. But I don't think many people use this, so it's not that bad. The asset importer.user data. To get an asset importer, by the way, you just say, I think it's asset importer.get asset importer or get for path or something like that. And you give the path of the file that you want the asset importer for, and that lets you do a bunch of things. That's the thing that would give you the model importer or just a general asset importer if it doesn't have a special type. And if you set .user data, it stores just a string in the metadata, and then you can either just do key value pairs or a JSON object there to pack whatever special string type data you want. Another trick that we do with this is we use an asset modification processor, which a lot like the importer processor that I showed you. If you extend this class, it will get a message anytime an object is about to be saved, deleted, moved, and there's a couple other things that it does, or renamed. If you extend asset modification processor, you'll get a message saying, I'm about to save these 5 objects. Here are their paths. And you can say, oh, well, this looks like it's a scene, so I'm going to update the scene metadata. So you'll have the hook to keep this data in sync with your scene file. And then you can take that data that's in your meta file, and you can display that in an inspector without having to load the scene. And I'm going to demo this. Lots of switching. So I'm going to go back to my scenes directory. Which side? There we go. In my scenes directory, if I click on one of these scenes I have here, you can see this gives me a count of the objects. And this is a custom inspector that inspects anything that has a .scene extension. So this is cool. If I open this up, I can see the contents of the scene, the contents of this scene. Regardless of if they're open or not, you can see the count. If I were to duplicate this game object and save, oh, I lost the script. Yeah, it will update the scene count. Even cooler, a very useful feature is if I drag in my prefabulous and prefabosaurus, let's put in another prefabulous, why not? And if I save the scene then, not only will that add to the object count, but this is also, when it hooks into the asset postprocessor save, or the asset modification processor save, it counts the objects. It also counts prefab usage and saves all of that in the meta file. And this is another scene? Yeah. So even if I unload the scene, if I load up another scene into memory, this one's not loaded anymore. When I select it in the inspector, it'll tell me how many objects I have and what prefabs are used and how many. So if I click this, it'll just ping the object. And this is a really good way to get a handle on, oh, where are we using this character? Are we using them anymore? What scenes are they in? And it's useful for the inspector, but it could be even more useful if you write a script that steps over this data just to do, find me all instances in all of my scenes for this guy. You don't have to load every scene into memory to do that check. I want to show you the text of this, if it isn't too much work. So the actual meta file text, yes, it changed again, did it? Looks like this. Your user data just is a string, and I just used key value pairs because it was simple. Asset path for the prefab, and then the count of the items used. And then we just parse this when we use the custom inspector. So many windows. There we go. So not all of the stuff that we're doing is editor. I do have some tricks for runtime, but they won't be as dirty as any of the editor tricks because you have to keep runtime safe. One of the things that was a little difficult to understand at first when using Unity is how asset loading of references works. And take, for example, in a game, if you want to have a list of all of the assets for some certain thing. If you have an inventory of hats and you've got a list of 1,000 hats that your character can equip, and you want to have that list available at all times because I want to open my inventory, I want to see what their names are and everything. If you were to take that list as a prefab or scriptable object and connect your assets, drag and drop your assets into that list, it's going to count those as dependencies, and it will load those dependencies when you load your list, which is wasteful because you don't want to have 1,000 hats loaded in memory at once. You can only equip one unless it's TF2. So the object references in those prefabs, it loads them all at once. And the other option you could do is to take, instead of dragging and dropping your assets in, you could type in the path of the asset and put it in resources. The nice thing about resources is that it's going to load everything only when it's needed, since you just have the string path. It's up to you when you call resources.load. This solution is a little crummy because you don't want to hand type everything. It's typo prone, and then you're just going to have a mess in QA finding out that, oh, we mistyped all of these different names of objects. So the solution that we have for this is to go with the scriptable object solution because it lets us defer loading of assets, and we need a string path to load a scriptable object. But instead of having people free type, we're going to put it's still going to be stored out as a string, but we're going to put a property attribute on that string that lets it look differently in the editor. So we have an asset path attribute that applies to string fields. And it will just look like this in code. If I have this is from the animal example, a man reference. And then if I instead have a string path, if I throw the asset path attribute on there, I specify the type that it's looking for. That way we can do some editor time checking to make sure we have the right type. And then this true specifies this should be in resources. False would allow it to be anywhere in the project. And then you make a property drawer for that property attribute, or for that attribute. And that property drawer will still keep everything serialized as a string, because that's what your type is, but it will instead draw a different inspector. So it won't draw like a string inspector. And this is how it will look. Your reference to a man is just, this is what you would expect to see. But instead now this string, which we would expect to just see it like this in the path section here, which is just part of the property drawer that shows you the actual text, it has an object picker, object field, an editor object field there, so you can drag and drop your asset in, and it'll automatically fill in your path. And we do have time for that, so let's do it. So this thing points to some things. And let me clear this first. I drag and drop this over, and you can see it just acts like it's dropping it in. I'll switch to the debug view of this so we can see the actual data. In debug view, you can see that it just stores strings for the bottom two types, and we can then load those from resources and not have typos. Is this my window? This is my window. The other thing that's kind of annoying at runtime is that you don't have any availability of what levels are in your scene. I already talked about earlier how I think it's kind of weird that there isn't a scene type, but there really isn't much information about scenes once your game's running at all. And it's kind of annoying because you know at editor time, you drag and drop them or add them all into the editor build settings. So the editor build settings has a list, so let's steal that list. We're going to revisit the asset modification processor, but this time we're going to hook it up to the editor build settings. So the asset modification processor, like I said, it gets a save function, gets called with an array of strings. And the strings represent the paths of assets that are about to be saved. So if one of those assets happens to be named editor build settings.asset, you know that it's about to save something. And you can use that as a notification of saying, my scenes in my editor changed, so I need to update some other list that I have. So we have a redundant list that is available at runtime. It's just a scriptable object in resources that will get a copy of all of the scene data when this happens. And editor build settings.scenes gives you that list, and the message to do it is your asset modification processor. And then once you have that list, you can add any custom data you want to it. So if you want to specify that this scene has this name or anything like that, you can add that to that list once it's generated. And it will look somewhat like this, but I'm just going to jump to a demo rather than show it in here. There it is. It's cleared out. If I open my, that is so far away. And now it's so close. If I open my build settings and I just make a change so that it will get saved, when I click save, you can see that the level list updates because it hooked into the the modification processor. And now this is something I can load at runtime and say it can do checking before I try to load my scene to see if it's a valid scene. Or what we use it for is we take this and power a debug window with that lets us hop to any scene in the game, and it's guaranteed to have everything in there. Yep, there we go. All right. So the next step, I wanted to talk about using reflection in C# and using reflection in Unity. My goal is to make sure this kind of makes sense by the end of this section. First, a little bit of a background, a primer on reflection. Reflection is a feature of .NET languages of C# where you can find out some additional information about the program that's executing. It lets you look up all the assemblies, and it lets you look up a list of types. And I've done that a ton of times so far in this demo. It's really useful for editor tools. And once you get a list of types, you can actually look through that for a list of all of the functions, all of the fields, whether they're public or private. So you can get a list of all the private fields and private functions in your type. And then what's even cooler than that is you can call any of those or set any of those fields, even the private ones, which is fun and dirty and unpredictable and just fun. And there's many different ways you can use this, and this is kind of a very standard example that we've done. Working on the world of Lexica, it's a large team, and it's not just us building applications for this. There's a lot of external vendors that are building things. So we actually developed an API that everybody had to use to hook into communication with all the games. And an important rule of API design is don't make anything public you don't want anybody to call. Even if your documentation says do not call this, it will be called. So you can still put some of this stuff in there, and that makes it difficult for you to be able to test and debug your release builds, or just to see where everything is failing. So one thing you can do is you can attach to your API with reflection. You wrote it, you know what the functions are called, you know what things you can set and can't set. So this is a really useful tool for debugging, so you can pull out values of things. And this is very likely what Unity is doing when you look at the inspector and you switch to debug view, and it shows you all of your private fields. It's because you can reflect a field that's private and get its value. Great for debugging. Another thing is this is really good for testing. You can take a function or grab a field and inject data into it to simulate some situation happening. And that's a very useful thing for us for skipping part of the games that use this API. We can just kind of inject when statements in there so that we can skip over something if there's a bug. This is the light side usage of reflection. This is you calling into your code. It's safe. It's just all happy. Somewhere a little darker, we have calling inside of Unity, calling into editor code from game code. Now, you can define a game object, define a model behavior that's a game object that is in your game code that uses the Unity editor assembly. And that's bad at runtime. It will fail on device. It will work in the editor, and it's actually pretty convenient. If you're building to DLLs, it's a little trickier because you can't link to the editor assembly from your DLL, because if you do that, it's going to be attempt to pack in the build, and that's just not going to work. But one very useful thing to do with this is select an object in the scene hierarchy. So if you are playing in the editor, you're running around the world, you tap on a character to talk, or in the editor, you click on an object to start a conversation with them. It's useful to have it also be selected in the scene hierarchy for debugging, just to find where you are in the scene. Otherwise, you're navigating around the scene view trying to find where you are. And you can pull this off if you're in a DLL by actually reflecting that call. But a more exciting piece of this is you can call your own editor code. So the compilation order, the dependency structure of the editor code and game code is that your editor code is aware of your game code, which is a very good thing. It has to be. That way you can have an editor script that generates game data. Your game data cannot know about your editor code, otherwise you have a circular dependency. Well, that's kind of, you can be mean with this. Only do this in the editor. Because the editor, it won't work if you're not in the editor. So what you can do is something simple like this. So I popped up that scriptable object selection window earlier. This is code that will open that from game code in the editor, because that's not going to open on an iPad. Type.getType is, it gets a type. You specify the name of the type you want to get, scriptable object creator, and that's going to be your fully qualified name if you're using a namespace. And it's a strange syntax because it's still one string with a comma, and then the second part is the name of your assembly. If you're building to DLLs like we do for our project, this will be the name of your assembly, and you should know that, hopefully. If you're just using loose scripts and you're trying to call into editor code, it's in the assembly-c#-editor assembly. So this will get you that type even at your runtime code, even if you didn't say using Unity editor. Then you can say get method with that type, and you specify the name of the method. The really cool thing is your binding flags, which is your next argument. So you want to say it's non-public. I want to get a private function from a object I should not be allowed to talk to. And this one's static, so the static thing is there. And then you call invoke, and this will just call it, which is cool. So now you can kind of create that circular dependency that all good structures are trying to avoid. And this is a nice trick. It's nice to be able to do it, but you are, in this case, calling code that you wrote again. You're just kind of throwing a message over the fence. It's almost like sending it into the future. Pat, what? You're sending it somewhere, and something's calling it, and it's fun. But there's an even darker way. I already stepped through that. I'm going to demo it first. OK. I changed that slide at the last minute. Yeah. So to demo this, I have a window. It's over here now. Play. If I alt-click on this guy in the game view, it will just call select object in hierarchy, which you can do already if you are not using DLLs. So I can use that to quickly say, what's the thing that I'm looking at right here? Oh, there it is in the object. That's why it's acting weird. If I control-click on it, it will execute that code I just showed you. It opened it over here. I promise it wasn't open already. And it will open this window, which is the scriptable object creator, which I wouldn't really want to use in this case, but it's great for a demo. It's a window I already made. And so that's all good because you're calling your own code, but there are some evil uses that you can use for this. This is more of the dark side of the reflection. Unity gives you a lot of features out of the box, tons of functionality, and it's growing every day. Even some of their stuff that's private is being made public with new releases because why not? It works, and it's safe enough for other people to call it. But there's still a ton of other things to explore that's private inside of Unity. I'm going to help you explore that. You can browse it with ILSpy or Reflector. I'm sorry, Unity engineers. If you guys use this, ILSpy is free. Reflector, I think, is paid, but they do the same thing as they show you. You can point it to the Unity assemblies, and it'll show you all of the classes, all of the types, and then all of their private stuff as well as public. And these even include a decompiler to show you some source code. Again, I'm sorry. You are literally looking at their privates, so don't judge them. So this is powerful to find out, here's something that seems really cool. I want to use this in some way. What way do I use that? We've used it in a few different ways. Mostly, all of it in the editor, and none of it should be a dependent call for your pipeline. You can't have your pipeline built on this, or else it'll fail, because it will fail. So lots of editor or window manipulation, making windows dock together, cool things like that, and opening windows, issuing commands. Some cool layout things like saving custom layouts, which I'll show you. Borrowing editors from the asset, or borrowing assets from the editor, which I have a sad story about. And there's just tons of other private calls in there that it's just fun to dig through and see either features that are not quite ready for prime time or features that you just really shouldn't be calling. So this is the story of icon content. One of the first things I did this with, we were working on an animation editor, and I really wanted to, I don't like making editors that have asset dependencies. I don't want to say, here's the source code, and here's 3 icons that this editor needs. I just want to be able to give out the source code. So I've gone far enough to I'll just generate this texture on instantiation, whatever. So when I was doing an animation editor, I wanted a play button and a pause button. I'm thinking I've seen a play button and a pause button somewhere in the Unity editor. All right, let's see if we can take it. And we were on Unity 4.1.3 for our project, and it's a huge project, long timeline, so we didn't upgrade that because we're in QA now. So in Unity 4.1.3, I wanted to grab a hold of that, so we reflected it with this piece of code. I updated, when putting this presentation together, I took all my stuff and made sure it worked in 4.5, and I found that they made this a public call now. So you can use this without having to reflect anything. And I brought this up in one of our engineering meetings that I was sad because I was excited about it. And Adam Serdar, one of our engineers, said, that's cool. I don't know, cool. But he said that just makes us API hipsters because we were calling icon content before it was public. It's called icon content. You probably never heard of it. But there's still other things that exist that you can still be pulling out stuff that they don't want you to pull out. So this is a simple amount of code that does a window layout file that you can add on source control. When you create a new layout in Unity and you save it, it's going to hide it into some hidden directory, which you can get to. You can copy it and you can share it with somebody. But a lot of times, especially when you're building your own custom editors, it's useful for some of the team or all of the team or people to share layouts. So to do that, I reflected a private class called window layout, or I think it's an internal class, but same thing from the perspective of somebody who's not allowed in, and built up a path, because the window layout has a function called save window layout. And that takes a file path. So internally, Unity only ever calls it with one file path, that one that's kind of buried in some settings. But if we give it our own path, we can force it to save into our project. And once it saves in our project, we can put it on source control. Once it's on source control, somebody else can get it and click a magic button on a special inspector and load that. And I'm going to demo that. I'm not going to demo the runtime. I already did. So I'm going to click this drop down here, demo, save shared layout. This is going to use that code that I just showed you, reflect into this call. And it's going to save my layout into shared layout right here. I'm in debug. There we go. And I wrote a custom inspector for a .wlt file with the technique that we talked about already. And that's going to show a button to load the layout. So if I do something like take my inspector and move it over. I don't know why it's doing that. I know what's going to happen. When I click load, it's going to put it into the right position, and it's going to pop it to this monitor. If it's something with this dual monitor on this laptop, it's just forcing everything to go on monitor 1. So I'll drag it back, but you have to take my word for it that it's going to look right on my screen. When I click load layout, it's going to put the inspector window back over here, because that's where it was when I saved this. And then for some unknown reason, it's going to move the entire window over here like it did even when I wasn't executing any of my code. This is somebody else's code. So load, oh, look, it's over here. And the inspector's back where it was supposed to be. And actually, I didn't even know it did this, but it saved that it was in debug mode. So I just learned something. I'm going to try that. I just want to see. Save. It's going to just save it in the same thing. See, it even put it over to this monitor then. But that's a really cool thing. Then this file can be something that you put on source control, and other people can download it and just use it. So you can have 5 of these if you write something that's a little more elaborate than that single drop-down box. So there's a lot of different tools you have to sort of get over some of the small holes in the Unity editor. Most of them small holes. They're closing them very quickly. They're making all these private things public because they're good, and they should be public. And they're closing a lot of gaps in the other drawbacks in the editor, like their list reordering and things like that people used to try to just hack things into. So they're improving things all over the place. But I still encourage you to be API hipsters and to dig into the code and try to find out what is the next feature we want them to release. What can I break? If anybody has questions or wants to see more code samples, I can take those. Microphones, if you can. Or don't. No. Yes?
First of all, nice job.
All right. I'll repeat the... Oh, there it is.
Can you hear me? All right. So I know you talked about metafiles and modifying metafiles.
Oh, this is rough. Yes.
But like generally, we try to prevent people from modifying them because you could break the prefab linking.
Mm-hmm.
So is that something that you guys have run into a lot with
So,
a large team like that?
If you're modifying the meta file, there is a section called the user data section, which is something that you can modify. And if you don't touch the GUID, then it won't break the asset connections.
Right. It's more like for us, like we see modified metafiles, like we're concerned that people might be breaking like those prefabs
because
and stuff.
they pop up in source control, and you're like, why did this happen? So that happens a lot in our project, and I found that generally that's because somebody duplicated a directory, and they duplicated all the meta files by doing that, and it's assigning a new metadata. So usually, if they're showing up as changed, it means something else is going on, because it shouldn't generate new metas sporadically for a file.
And then my other question was more for the actual mono debugger.
Mm-hmm.
Have you found any like hooks into like adding additional projects, like when it rebuilds the project settings and things like that, so you can add your own custom DLLs and things.
In the mono debugger, no, I haven't worked. I've avoided mono. We develop in Visual Studio, and this demo I did in mono, but no, I'm not too familiar with fixing the debugger.
Thanks.
Thank you. Yes?
Hey, I had a question about the asset importer with the scriptable object defining the overrides.
Mm-hmm.
Have you ever run into a problem with like bootstrapping that and having an import order problem?
It's so annoying.
Yeah.
The solution that I don't want to do is to write an asset importer.
And what would that look like?
So when the asset importer gets imported, the problem could be that the assets that it imports have already been imported. So if that's the problem, you write an asset importer, then it re-imports your asset importer. Actually, that could break too. You need an asset importer.
Yeah, like because we tried to do something like this and wound up talking to Unity Tech about it, and they were like, I don't think it's like possible to work around the bootstrap problem quite yet. Like you need something to tell Unity like completely externally, like look at this file first.
Right.
And like we really wanted to do something like what you had, but we couldn't do it like 100% reliably because of like this ordering problem, this import ordering problem. We have that with another similar process to that, where it's only when people are doing their first time build it'll pop up, and our solution is re-import. It's not an elegant solution, but specifying the order of saying this needs to be imported first would be nice, but that is a drawback. Thank you.
Yes.
Hey, one of the things that I ran into is that sometimes you've got a prefab with lots of kind of nesting and you can only see 2 levels in.
Yes.
And although generally you probably don't want to see too many levels in, but I'm wondering if you found anything in the private APIs to...
So I'm your private API Sherpa. I haven't looked, but that's actually would be a cool thing to look at. My guess is that it just stores some cache data about it. I don't know, but
Or I wonder if you could make like a custom editor script to view
that could be cool.
'Cause
Save
I know you
meta.
can still click on them.
Yeah.
That it works.
Nice.
So we did it. I can maybe share it with you, but it's helpful.
Sweet. I guess question
All right.
answered.
Well, there you go. Thank you.
It's, API is sort of public. So I love your point about storing the path to a resource instead of just a resource directly, just to save it. And in editor, we have this bunch of atlases, and there's a whole bunch of metadata and meshes attached to it, and we don't want to load all of those.
Yes.
But there's sub-assets.
Mhm.
Have you found any way around that to load sub-assets by path? Because you can't really.
you-
You don't
you
have
can't,
a GUID and...
So to load a sub-asset by path, or to only load a sub-asset in memory and not all the others?
So basically, we would want to load the main asset just at some
Yes.
point, and then load the sub-assets only when asked for them.
Oh, okay. Yeah, so if you use the solution that I showed with the asset path attribute, if you drag in a sub-asset, it will just give you the path of the root. So
Yes.
it doesn't point to that. So that
Yeah.
doesn't solve that, no.
Yeah. Have you run into the same problem, or?
We've never used it for any of those files because those always end up being also scriptable objects, so they're not large files in memory. All of our meshes and things are the larger ones that are not nested, but no, I don't have a solution for that.
Too bad. Thank you.
Maybe reflect something. IL spy. All right, well, thank you.